If you're planning to join the fun on the water and don't know much about outboard engines, you're in the right place. In this video, we'll discuss some general information about outboard motors, their primary types, their components, and how they operate. So, let's dive right in. There are generally three types of boat drives, including inboard, outboard, and stern drive. One obvious distinction among them is their placement of the motor in the boat. An outboard motor is the propulsion system completely installed on the outside of the hull, typically mounted to the exterior of the transom to power the boat. This is distinct from an inboard engine, which is typically mounted inside the boat and invisible, or a stern drive, which combines an inboard and an outboard engine. An outboard engine is mounted on the boat, which provides both propulsion and steering control, since it is designed to rotate over its mountings and change the thrust direction. An outboard motor is frequently the first option for inshore fishing, recreational, and small commercial boats. These engines offer dependability and user-friendliness, which makes them the most popular way to motorize and operate a boat is using an outboard motor. This is especially true for small and medium-sized boats due to its propulsion technology and its reliable means to cruise on the sea. There are three primary parts which makes up outboard motors. These are outboard powerhead at the top, midsection, and lower outboard unit. Let's discuss each component properly. 1. Outboard powerhead. The outboard powerhead, or top section of an outboard motor, is made up of different parts that make up a combustion engine. The engine cylinder heads, pistons, and valves are all housed within. The skeletal framework of the engine comprises the following elements and forms the powerhead. A. Engine block. The engine's moving parts, such as the pistons, crankshaft, and piston rods, are housed in the engine block. The pistons are in the cylinders, which are also part of it. Depending on whether it is a 2- or 4-stroke motor, the engine strokes take place inside the engine block. B. Crankshaft. Inside the engine block, the crankshaft is where the pistons are connected. The crank turns around the pistons as they rise and fall to provide power. The piston and the crank are connected by piston rods, which raise and lower the pistons inside the cylinders as the crankshaft rotates. And C. Cylinder heads. The cylinder head, another component of the engine block, is located above the cylinders. The camshafts, spark plugs, cams, and valves are located here, depending on whether the engine is a 2- or 4-stroke model. Another important element to note are cooling tunnels, which are built into the engine block, cylinders, and cylinder heads. These are essentially passages that let water that absorbs heat pass through the powerhead. This prevents the engine from overheating to the point where metals could melt. In the cooling tubes is a thermostat that controls the temperature of the water passing through the engine. The thermostat's responsibility is to keep the engine from getting too hot or too cold, both of which can lead to disastrous problems. 2. Midsection. An outboard motor's middle portion is a metal case that joins the engine to the bottom unit. Its primary job is to serve as a conduit for attaching the parts of the engine to those of the bottom section. A bracket in this region is used to secure the boat's transom to the motor. This enables the boat to be steered and the engine to turn in various directions. Smaller boats frequently include a tilt mechanism that enables the engine to be raised out of water. An electric motor that raises and lowers the engine at the push of a button is found on bigger outboard engines, as well as some smaller ones. The drive shaft housing, the primary structural component of the engine, is in the middle. A water tube that joins to the bottom unit and transmits cooling water to the powerhead is part of this. The drive shaft, which transmits rotation and turning to the bottom unit, where the propeller is also situated in the section. The midsection, which joins the powerhead and lower unit, is essentially what holds the engine to the boat. 3. Lower outboard unit. The drive shaft enclosure, which is directed towards the bottom unit, is principally provided by the middle part of the engine. The water pump at the top of the unit will have to be traversed first, though. To keep the engine cool, the outboard draws water from the lower unit and pumps it into the engine. A rubber impeller inside of this water pump pulls water and propels it up through the middle of the engine. A shift shaft is located at the top of the lower unit and enables the boat's driver to switch between neutral, forward, and backward. A clutch dog that swings back and forth to engage within the forward and backward pinion gears is linked to the shift shaft in the bottom section. The forward gear corresponds to 6 fingers and the reverse gear to another 6 fingers. When they mesh, it moves that gear, which is attached to the prop shaft, and turns the propeller to propel the boat forward. The outboard motor can be divided into 2 categories: the petrol outboard motor and the electric outboard motor. Large boats are frequently equipped with petrol outboard motors in the marine industry. A petrol outboard is the best choice for power and speed if the rising cost of gasoline is not a worry, and you can put up with the racket the motor makes. Despite this, the use of electric propulsion for boats is expanding and getting better. The market today offers a choice of long-range, high-quality, and powerful electric motors because of its continual improvements. An electric outboard motor offers a simple, low-maintenance alternative that is clean, quiet, and intuitive, improving your boating experience. A petrol-enabled outboard motor works with the help of an internal combustion engine with a piston design that burns the mixture of fuel and air inside its cylinder, producing high-temperature, high-pressure gas because of the heat that is produced. The kinetic energy needed to drive the boat ahead is created by the gas expansion, pushing the piston to work. The mechanical work is then output through the crank connecting rod mechanism and the propeller. On the other hand, the electric outboard motor can use the recycled battery as an energy source and convert the electric energy into kinetic energy through the electric motor. Range anxiety is a common concern when discussing electric boats. Sailors can use the hydrogeneration feature, which enables you to generate power from water and the wind. In both ocean and fresh water, it can power aluminum fishing boats, dinghies, and cruising sailboats. Based on its operating principles, it is simple to conclude that a boat with an electric outboard engine is emission-free, smell-free, largely maintenance-free, remarkably quiet, unconcerned by fuel driving restrictions on the water, and does not frighten off species. An electric outboard engine is ideal for us when you want to take a boat trip to unwind and enjoy the scenery. Additionally, the operational expenses are considerably cheaper, which may be advantageous financially for regular drivers. Electric outboard motors are enticing substitutes for gasoline ones, particularly for tiny engines. And there you have it, a detailed explanation of how an outboard motor works. We hope you found this information helpful and informative. Remember to take good care of your motor, and it will provide you with many enjoyable boating experiences. If you have any questions or suggestions for future videos, please let us know in the comments below. Don't forget to like and subscribe to our channel for more exciting content. Thanks for watching, and happy boating!